Thanks for attending Schematic Design Made Easy as we take a first look at SOLIDWORKS Electrical. We'll be running, by the way, SOLIDWORKS Electrical 2016 Service Pack 5. So depending on what version you would get started on, there may be a few differences, but I think you'll like what we have to show you today. So to begin, I just want to go through some of the background with SOLIDWORKS Electrical and looking at getting lightning fast electrical design at your fingertips. So what we're going to look at is, first of all, your design processes, and taking a look at how SOLIDWORKS Electrical will help some of those processes along the way as you face your daily design challenges. Design challenges as an electrical engineer, as a design team, can come in a couple of forms, whether that be time spent putting a design together, modifying changes, and of course keeping tabs on all those changes with your documentation. And this is where SOLIDWORKS Electrical fits into both of those worlds, whether it's processes or design challenges. The target is that SOLIDWORKS Electrical meets both of those needs for your department. My background, real quickly, I was a power and communications engineer, worked in the field for around 10 years, and joined GSC, it was August of 2016, so I've been at this for over a year now. And one of the things I loved about my old field that has really carried over to working at GSC is just no 2 days are the same. I get to work with a lot of really great customers, really great design challenges, and I love that problem solving that is required on the job. So the question we're all here to answer is, why SOLIDWORKS Electrical when it comes to the ECAD landscape? When you look at your design process, what a lot of managers tell us is their design team spends maybe half of their time doing actual design work, putting together schematics and making actual design decisions, inventing and creating. The other half of the job is the part that they never told you about in college, the documentation, the checking, doing spreadsheets, Excel, going through data sheets, keeping tabs on all of those changes as you work through your design. So here's how maybe a common electrical design process currently works. Obviously there's differences with every situation we come across, but you may start with a logical definition. So you put together your schematics, you put together your part selections, you draw your point-to-point drawings, whether that be in a CAD package of some kind or maybe even on the back of a napkin or passing sheets of paper between cubicles. From there, you go about documenting what you've been doing, and of course, after we've documented, there are always design changes, your ECOs. How do we audit those changes? How do we make those changes and verify consistency across our design? This is where SOLIDWORKS Electrical tries to make all phases of this easier. So first of all, putting together your drawings easier with a SOLIDWORKS level user experience, and then managing all of that background metadata by fully automating a lot of these error-prone manual tasks, or clerical CAD as we like to call them. So these are the top 5 issues that SOLIDWORKS Electrical really tries to address. So first of all, putting together a design, and we will be doing that in just a minute with our demo, demonstrating some of the helpful workflows that the software has embraced. Along with that, when we reuse design, we're reducing errors. We're also reducing errors when it comes to the documentation and double checking all of your numbers, all of your wires, all of those things. We also have built-in ability to do engineering change orders, so those can be time-consuming, error-prone, and the software manages those very well, but also gives you a lot of flexibility and customization. And then the last part is, when you have a good working design, it gives us the opportunity to leverage that good working design in future projects by reusing large chunks of schematic or even pasting sheets and entire design books at a time. So how does this all work? Well, that's the big question. When we're talking about SOLIDWORKS Electrical, we're talking about a parametric ECAD tool. What do I mean by parametric? It means it's based on the parameters that we've set up in our SOLIDWORKS Electrical design, and those are all housed in a Microsoft SQL database. So anytime we place a symbol, anytime we place a part, anytime we draw a wire or a cable, that's an entry in a database. And the software keeps tabs on all of that constantly and pushes those changes throughout every part of the design to keep everything up to date and current and minimize a lot of that backtracking whenever a change is made. So real quickly, I want to look at what it means when we make one small change in a design. And this may ring true for some of you who are doing a more manual process between a 2D CAD tool and some kind of a spreadsheet for all of your documentation. Let's say we were to change just one relay in a schematic design. What would that impact in the rest of our documentation and in the rest of our drawings? Well, first of all, there's the cable interconnects. Then there's the control wiring. We've got cross-references that these relays work with. We've got our part numbers. We have our symbol tags. We have our terminals. And all in all, we're talking about 48 items just for one simple component change. Now, these are things in the past. You've had to go back and make these changes one by one and keep tabs. And really, you as the engineer were the only one who had that knowledge of how to go through and make those changes. So this is what we hope to show you today, the key benefits of SOLIDWORKS Electrical. First of all, we're talking about faster schematic creation with fewer errors. We'll be going through a package control system. So might not be quite what you're working in. It depends on your industry, of course, but I think the goal here isn't necessarily to draw schematics similar to what you have in building, but to show you the ability to put these schematics together quickly, whatever type of industry you're in, can be brought to life much quicker and with fewer errors. We're also looking at managing that content. So all of the metadata and then reusing that data for saving time and also cutting down on errors. As we make changes, how do those changes push through to the rest of the software? And then, of course, our final deliverables. This is the bread and butter. This is what gets your project actually built on the floor and out the door. So how do we generate our wire to froms, bill of materials, cables, all of that information. So with that said, let's begin to take a look at SOLIDWORKS Electrical in action. So to begin, we have a blank project, and what we're working through here is just a package sorting system. So we'll have a few motors out on a line, and we'll have some sensors that are interacting with those motors. And what I've begun with here is what we call a template. A template in SOLIDWORKS Electrical it's a head start. So saves a lot of time on our project creation, filling in all of our details, whether you're in ANSI or IEC, whatever your normal page formula numbers are, your component numbers, wire numbering, what kind of symbol libraries you want to use. All of those things can be put in place so when you begin a new project, you've cut out a lot of the initial stages and stepping through for your project startup. So the first thing we want to do together is fill out this power schematic. And I have here just a simple blank schematic sheet. And you'll notice that anytime I open a sheet in SOLIDWORKS Electrical, my panes on the top change to adapt to whatever I'm working on. There's a lot of contextual sensitivity, we call it in the software, where it's making things easier to find. There's a lot less menu hunting, and it puts a lot more at your fingertips. So in this case, we're in a schematic, and I've now got tools that pop up related to schematic creation. Additionally, on the right, I have a nice little property side panel that's going to be displaying all of the properties of the components, the symbols, the wires that I'm working on the fly. I also have at a fingertips grab macros, which are design chunk reuse, ability to quickly search and add symbols. And on the left is my document tree. So these are the schematics, the cover pages, reports, terminal strip drawings, and many more that I can quickly access and navigate in a browser style setting. So as I add new sheets to my open setting, they're all appearing across the top, and I can quickly navigate between them. So for our first sheet, let's get started just putting down some basic three-phase AC wiring. And to do that, we use a draw multiple wire command. Now this selection of wires was created and added to my template. So when I began the new project, these were brought in by default because this is, let's say, a company standard. Now when I begin working on drawing, you'll notice a couple really nice things. First of all of these draw together with a set spacing. And you'll notice I've got phase 1, 2, and 3 as well as a ground, which I can easily place and then begin drawing out some legs for a motor starter group. So we'll continue drawing, and it does some nice things here as well. Like when I begin to insert the next phase, it makes sure that, number one, they're branching off and they're not going to cross. And it also makes sure that the wire type is staying consistent, so that phase 1 is not getting crossed over. I can, however, do some phase crosses and add some extra bends by using some of these side commands or spacebar as a shortcut. In this case, I'm just going to draw a simple 3-phase leg across. And with that, we've got the beginnings of a place to start putting some of our 3-phase components. Now at this point, we're ready to insert some symbols, so I'll show you a couple of ways to do that. First of all, in our schematic tab, we have an insert symbol command, which would bring up our entire library assortment of available symbols. When you're working in the tool, you're very familiar with your own library. This is a great way to go. However, in this case, I want to show you another way to insert symbols, and that is using our symbols tab. So this is kind of a greatest hits of all of our symbols that we typically use in our designs. This is completely customizable by you in your operation. We can add new groups of the types of symbols we're going to be typically working with, but I also have here a Google style search that lets me find anything matching my description, and in this case I'm looking for a motor. Now in this case I want a 3-phase AC motor, so I'll just pick this symbol, and note when I place it on the sheet, depending on what CAD package you worked in the past, things like putting this in line were kind of asking for trouble. You'd want to place this at the end. Well, in SOLIDWORKS Electrical, it does a nice job of trimming out extra wire length and also healing wires. So anytime I move this symbol now, it's going to keep trimming off that wire nicely, so I don't have to do any of those extra clicks and risk carpal tunnel in my older years. So I've placed a motor symbol, and now let's put a main fuse in line. And again, I'll just use my shorthand search, and I want a 4-pole fuse. And notice when I drag this across my wires, it automatically is gripping to those wires and latching on. So when I get it oriented such that it will be in line with all 4 phases, 3 phases in the ground I should say, I'll be able to place that symbol and it will snap in and trim off the wires like I've shown you before. Once those symbols are placed, we can now put in some of our controls. So we'll add just a breaker here. And again, just using the quick search function makes it very easy to find what I'm looking for. So I'll put in the breaker, and we'll also put in a contactor. And there, we've got the beginnings of something already showing on our sheet. Now, one thing that we do in SOLIDWORKS Electrical is once we put symbols in place, we get to actually define what the actual circuitry on those symbols are by assigning manufacturer parts. Now again, we can do this a couple of ways. So just like when you're working in Windows, lots of ways to go about performing a task. In this case, we've got some nice button clicking, button saving commands. So in this case, we would just go to component and assign a part to the symbol. Now as I look at my screen here, I have a Boolean search, so I can always narrow down such as, well, I want a 4-terminal motor, show me all the results, and then I can pick from my available library entries to match a part to the symbol. I also get a preview down on the right when I've selected a symbol. Does this symbol match the part that I'm picking for it? And in this case, when it is a match, all of these terminals will turn green. So finally, I'll add that part, and you'll see all of that part data that was in my database pushing through, and it's now associated to this motor. Okay, so we will go through that real quickly as well, assigning parts to fuse 1. And again, the idea here is saving on mouse travel and very quickly assigning all of the part data that will be populating our design and pushing through to our final reports. So again, find our breaker. The preview approves it. and we will assign a relay to this component as well. Now in this case, I hit search and I wasn't able to find this part. Why was that? Currently, because of the symbol I placed, it was a power contactor. It's looking for only manufacturer parts that are in the power relay category. The particular part I'm looking for by my custom manufacturer is actually not a subclass, it's in the main class. So by adjusting my search, I'm able to narrow down exactly what I'm looking for. So I've now assigned this part to that symbol. Okay, so at this point, we're looking at an electrical cabinet enclosure, and then what would appear to be something that's out on a line. And of course, to interface between those things, we typically want to have terminal strips and have our in-cabinet wiring interface at a terminal strip and then out to a cable. So SOLIDWORKS Electrical does some really nice things in terms of dealing with terminal strips, making their management easier and even automating the drawings. So I'll take you through all of that very quickly. So as I insert this terminal strip, it's going to create a new strip, X1, along with 4 terminals that are now numbered 1, 2, 3, 4. Additionally, these terminals are grouped together and I can manage them as such by going to my terminal strip manager. And what I get here is just a pictorial representation of what my terminals are, what's connected on either side, and again, what's the part that I have assigned in this case. Now here, I'm going to assign a simple single terminal block. And that part has now been assigned, and all of the terminals I have in place will be ordered and show up on my bill of materials automatically. But additionally, you remember, we had these just as wires. Well, what if I wanted to change that into a cable that's running out on the line for protection? I can use a command here called associate cable cores. And right now, I have no cables that this would be relating to. So I'll go ahead and add a cable. And again, we have our Boolean search operation to narrow down our options. There's a lot of cables in my library here. So I can narrow this search by going to my manufacturer. And now I'm closer to what I'm looking for. I wanted a 4-conductor cable. And this is a 14 gauge, which should accommodate the operation of that motor. So I will add that cable to the project, just like I did with my parts. And now, one for one, I can replace the wires in my schematic by assigning them to that cable using the associate cable cores command. When I do that, all of this data gets populated. And think about how much time that would have taken to go through and make all of those changes to my origin, destination, and packaging each of those wires inside the cable with their destination and origin as well. I get a graphical update that they're now inside of a cable, and with that, we're done generating our terminal strip drawing. So I want to demonstrate this real quickly as well. We can generate a new type of drawing called a terminal strip drawing based on our terminals. So let's take a quick preview of that. This new drawing showed up in my document tree, and the format of this we can customize. So just take note of that. But here we have our terminal layout. Here's our origin, our destination running through cable W1, and our ultimate destination, which is the motor. So very handy tool for quickly generating these terminal strip drawings. Okay, so with that in place, in my actual operation, what I would have here is not just one of these motor starter groups, but 3. Well, how do I quickly copy data in SOLIDWORKS Electrical? I've got a couple of options. First of all, I could turn them into a macro by clicking and dragging this into one of my macro groups, and from then on in the software, I'd have this motor starter group available to any of my users. But I can also just use simple Windows copy and paste commands. So that's what I'll do here. I'll copy and I'll paste, and attached to my cursor is all of the schematic information. I'll paste it again, and think about the time that that would have taken to recreate going through these one by one. couple more things to clean up. Our motors right now are currently assigned to our main location, which is the electrical closet. That's clearly not how we want our project to be. So what I would want to do is instead assign these motors to a different location to reflect where they'd actually be in my install. So going to location outline, I can draw a box around different items that I want to be located in a different spot. Select the location they'll be. And at that point, I can change the actual location of those components. So anything inside of this box is now out on my conveyor. Okay, we'll go through another example of that shortly as well. Now, a couple more design changes we can make. Notice as I copied and pasted, all of my tags also incremented based on protecting the current components of my design, making sure I didn't accidentally write over the same component number. Well, let's say in this case, I have my Q2, which is a relay coil plus a couple of contacts combo. But as I copied these, I know that there's an auxiliary contact that I could attach to this that would actually accommodate all 6 of these circuits. So instead of making another part and adding those to my bill of materials, I can add a different part and assign these to this driving component Q2. And this will all be resulting in cross-reference on the coil when I place that on my control page. So very quickly, I can reassign these components back over to Q2. And when I do that, notice that I lost my terminal information, but they are now assigned to the component Q2, and they'll occupy any additional circuits that I bring in as part of Q2. So why don't we do that very quickly? Let's find an auxiliary contact that would accommodate these 6 remaining normally open power contacts. So currently I have 34241, my contact relay. I'll add this 6-pole auxiliary power contact. And you'll notice I get the preview that those circuits are now occupied, and I also get terminal updates showing that these symbols are correctly assigned with a proper part. So final steps on this part of the schematic will be, we basically just need to make a power supply that will be sending our 24-volt control signal over to page 3, where our controls will be. So in this case, we could go ahead, draw wires, put in a power supply, etc. We'll make it simple, and I'll demonstrate how these macros work. I have a design chunk here called a macro that is a power supply. And when I bring that into my design, whatever I had set up with the macro comes out exactly the same way. So the wire types remain intact, the symbol and the part assignment remain intact, and my outgoing wires also remain intact. So this power supply is ready to be connected up to page 3. As a final step on this page, let's go ahead and number our wires. And again, this would be a manual process you'd have to be managing entirely along the way. When I add these wire numbers, I also have the ability to go back and renumber wires, make changes to my formulas, and handle all of that automatically behind the scenes. So very nice automated features. Okay, that wraps up page 2, our power page. Let's go build up our control circuits. And in this case, we're going to be drawing single wires instead of our multi-phase wires. Now, when I draw single wires, I'm not limited to just drawing one wire at a time. I can draw multiples of the same type of wire at a certain spacing to make sure I'm matching up to my component terminal mark spacing as well. In this case, I want to draw just a simple ladder diagram. We'll also do a point-to-point representation later on, but we'll just quickly demonstrate again some of the nicer things about working in SOLIDWORKS Electrical. When I'm drawing my wires, I get some little visual clues. For instance, when I'm lined up to the top of this wire, notice the dashed line appears, showing me that I'm actually directly in line with this wire. Now that I'm done drawing this, I can easily move these wires and notice that they now made a node in that location. So they are attaching live as I'm modifying my design. So again, we'll continue drawing, and in this case, our control circuit's going to have just a push button switch, a seal and contact, and then a coil and a light at the end of it. Now, these splices weren't there before, but as soon as I drew some of the other wires, it added those splices. So very nice behavior that's going to save us some time. So again, now that this is its own wire segment, I can easily delete that and begin filling out the rest of my schematic. Now, in this case, we could go ahead and find all of the symbols that we're looking for and place them. But there's another way to also manage inserting symbols, and that is using our component tree. Our component tree handles by location all of the different parts and symbols that I've been adding to my project along the way. Now, in this case, as you recall, we'd inserted Q2. This was that main relay along with the auxiliary contacts. And when I've put in a component, I can also insert symbols directly from that component based on the symbols that are still available. So I'll be inserting symbols from the available part circuits. So in this case, it recognizes on Q2, I already have the power contacts occupied, but I still have a coil and a contact that I can insert. So just a nice clean way of making sure I'm correctly using all of my circuits on my actual parts. So we'll put this coil in place, and you'll see it adopted that mark, and it also gets the manufacturer part information adopted here. And we'll go ahead and finish this up with that contact. So this will be our seal in contact, and again, that part date is applied. Now for the last couple steps, we're going to just go to a command tab, and like I said, this is kind of my greatest hits where in your operation you put your most commonly used symbols. So I'm going to put the rest of these in place and finish out my control drawing. So there's an e-stop switch, push button, and a light. Now, again, I can finish inserting my manufacturer parts to these one of two ways. I can go here to Manufacturer Parts Manager and add the part this way, or Component, Assign Manufacturer Parts. Just want to show you this particular manufacturer part has two functions to it. It's an illuminated push button switch, meaning I have a light that I can also associate the symbol to the circuit. So the push button fulfills the first part of my design, but now I'm going to associate this light to it as well. So again, we'll assign component, 3PB1, and this now has adopted that part circuitry. Finally, my e-stop push button, we'll finish that up, and we'll move on. Now, one more thing you may notice about this, I drew with a 24-volt wire type, but on the back side of my ladder diagram, I actually want this to be a control type of wire, ground. I can very easily replace everything on this node and push that to anything that's on the equipotential. So instead of 24 volts, my circuit would not work if that was the case. We'll take a ground wire and replace it all. And I now have a legitimate control circuit. Now the last thing, as you recall, we brought in a power supply on this page connected to my AC power. I want to actually make an invisible connection between these two pages to feed my ladder. So in that case, we use origin destination arrows. And this little icon actually helps us understand what this is doing. It's making just an invisible link between two spots in my design. And one thing to note about this is it won't let us make certain mistakes, such as combining a 24-volt signal to a ground. It won't latch onto it. So even if I wanted to connect to ground, it wouldn't let me. It only finds the same voltage wire as a viable option, and it only finds the same wire type. So if I had an 18 gauge here, but I accidentally drew 24 gauge over here, it would not recognize that that's a viable destination, because again, this is an invisible link. It's as if this wire was actually running to this point without crossing up our schematics and making for messy drawings with a lot of confusion. When I create these, they are a live link that lets me jump between these origin destination arrows, so that's a live cross-reference. And finally, I mentioned before we would be getting a different type of cross-reference, and that was off of my coil. So I inserted this coil, which was driving all of those contacts on my power page. So these contacts, well, how do I get a representation of those next to my coil? It automatically has inserted a coil contact cross-reference, listing out where each of these instances is located so that I can quickly track them down. I can also navigate quickly to any of the associated symbols by using a go-to command and navigating easily that way as well. So they have a live, intelligent understanding of where their other part circuits are. Okay, I said before we would be working on also a point-to-point style diagram. So to begin that, we have a PLC chunk that I'll be inserting. And this PLC chunk is basically just waiting to be built out with things like signal wiring and any kind of interface in and out. So here, I can easily drag my main wire down and attach this to it. And note, this signal already has a wire attached, a number attached to it, 305. Well, the wire I'm about to connect to also has a number 204. What happens when I connect these up? What does the software do? It gives me what's called an equipotential conflict. That's a little smart check, making sure I don't have two different wire numbers on the same node. I can easily fix that by selecting to solve the potential conflict, and then I just need to pick a winning wire number that will take over on that node from now on. So I'll stick with the first number I had put in place, 204, and now everything on that node is on the 204 wire number at equipotential. I will mention you can also number just by individual wire segments, so you're not limited to a node-only approach. Just need to mention that for people who use that wiring approach as well. All right, let's attach the ground here. And when I draw this, I want to just give it a little leg to connect to my ground circuit up here. So again, let's use origin destination arrows so I don't have to draw a wire all the way across and down. It'll just make it a little bit cleaner. Now again, it's only finding the ground as an option to connect to, so it's protecting us from making an accidental wiring error in my schematics. Okay, let's begin interfacing now to this PLC. And I want to add basically a sensing component. And I'll look for it here. So this is the sensing switch that I want to put in place. I also want to have this reproduced all the way down the line. So each of these inputs is going to be looking at a sensor that's out on my assembly line. And to do that, I'll build up one of these circuits, and then I'll just use a copy and paste command to save time on building out the rest of these. So let's finish drawing the wires running to that. So the output of this is going to my PLC, and I also want to draw two wires coming off of my legs. Now, what would happen if I used the 24 volt but tried to connect here while drawing two wires? Fortunately, the software recognizes that I'm using a different wire type by their spacing, and it takes over with the existing ground wire to make sure that I haven't caused a conflict. So as these switches will be out on our assembly line, I'll be adding some terminals and packing each of these up in a cable. So again, we'll use our insert terminals command, and I'll be starting a new terminal strip named X2. And the other side of this, the third lead, we will also attach via terminal and make sure that that's part of X2. I'm going to take away our attribute here. This attribute is just our symbol mark. Now, because I'm copying this all the way down the line, I'm only removing that attribute while I do a copy operation. Then when I'm finished, the first one in line, as these terminals all line up down the line, will have that X2 back in place. But while I'm making the copy, instead of undoing that attribute 5 times, I will take it away, make the copies, and finish from there. So to fully define these terminals, again, we'll visit our terminal strip manager, and I can assign parts right in place. And I can assign a cable on the fly, selecting again a cable that matches my criteria, so a 3 conductor with the proper gauging, and again, we will associate the inner conductors in that cable to the wires that are in my schematic. So I have my ground wire, I'll associate that conductor. I have my red wire, which is my power 24 volts that I'll associate, and my outgoing signal, which rides on the yellow wire. And now we have our cable defined. So at this point, the circuit's ready for copying and pasting. So again, we'll just use copy and paste command, line it up. And as I look at this, we may decide that I don't like how these symbols are in line. It's a little too tightly packed, so I can use a stretch command and move some of my elements around on the fly. So that's what I'll do here. Let's move that push button down the line and stagger those. So when they draw, it's just a little easier to read. Additionally, my text now got out of line. I can just use a text alignment command, select these, pick an axis to line them up, and just a nice time-saving feature. Now I'm really ready to paste these in. I have the 2 circuits, they're staggered, and I'll be saving again all this time on drawing, assigning cables, making the terminals, and renumbering everything. So you'll notice all of these marks incremented along the way. So finally, I mentioned we can change these attributes on the fly, either show them or hide them, whatever's most helpful. And the inputs to my PLC have now been fully defined. But one last thing, these sensors are going to be sitting out on the line, so let's change that. Using our location box to be on the conveyor, and we'll change those locations. Another way we can deal with symbols, macros are great for design reuse, but let's say this one design we're going to be drawing a component that we're really not going to be using again. This is a case where we use a black box, and this is kind of a one-purpose, one-time use component. Inserting a black box, I can, on the fly, change its designation. This is going to be a pneumatic hydraulic component, so just to mention that SOLIDWORKS Electrical can handle that as well. And I don't have a part assigned to this, but I'm going to define that part on the fly. So I can put in here a reference part number, and I can put in a manufacturer, and I can even define my circuits and terminals on the fly. I'm going to have 4 inputs and 4 outputs, so I'll quickly add 8 circuits here. And with multi-select, I can save a lot of time building up these inputs and outputs. So on the input side of this, I'll have digital PLC inputs. And on the output side, we'll have some pneumatic hydraulic outputs. So we'll change these to pneumatic hydraulic. And now I can go ahead and define on the fly all of these terminal marks. And again, using a couple of keyboard shortcuts, I'm selecting all of these at once. And just using a Windows copy and paste command to make this go a little quicker. And now for my outputs, we'll do the same with the copy and paste. So just some nice Windows style shortcuts that make navigating some of this manual input, everybody's got to do some of that at some point, a lot easier. Okay, we've assigned our part information. And I could even add things like a description. I want to define here my size of this particular box. And I've fully defined now on the fly this brand new part. So how do I make interconnects to a black box is the next question that would come up. The nice thing about black boxes is any wires that I attach to them become connection points when I refresh that black box. So let's put a couple assembly line items again, and we can connect this up from the outputs of our PLC. And at this point, we don't have any connection points showing up. So we'll just refresh this black box. And now all of those circuits have been populated. So we finished now our schematic design. Another step we can take in the software. We'll be wrapping up shortly, by the way. I just want to show you this really quickly before I finish with reports. We can generate 2D cabinet layouts. And so with my main electrical enclosure, all of these parts I've been placing along the way, I now can populate a cabinet with those parts. So first, we'll pick our cabinet and our backplane. And as I place these, notice that they might be a little bit small for my drawing. Well, when 2D cabinet layouts are in operation, I can scale these live on the fly. So I change my scale instead of 1 to 10 to 1 to 5, and now these should fit. And I have the opportunity then to go ahead and insert scaled footprints of all of my design elements. So here's a switch and a light on the door, power supply, all of these breakers, and my auxiliary and main relay will be placed together. I can put rails and space them, ducts, and finish out that 2D drawing also very quickly. So to wrap up, our project has led to this point where we've assigned components, drawn wires, and hopefully done everything in our power to make sure that we're getting a good design at the end. The final step of all of this is to generate our reports. So these are coming in a lot of shapes and sizes that come packaged with the software. And what we would be doing here is just selecting the different reports that we actually want to be creating. So when I choose to generate my reports, you'll see I've got, here's my bill of materials, wires, all of this data that's been just keeping track in the background is up to date and current. And you can see the variety of reports. These are customizable. And I can select which of these are going to get added to my document tree. So you see the list building on the left. I can also export these as an Excel spreadsheet, so I can always massage them and modify them on the fly, XMLs. And finally, my project as a whole, I can import and export as a DWG or a PDF to finish up. So let's take a look at how these bills of materials drew up. Again, customizable in a lot of ways, so your formatting may differ. But there's a great example of the kind of deliverables that the software produces. So to finish up, are there any questions? Feel free to type in the question window. Just a review of some of the things we did together. As we built out the schematics, you saw a lot of the little tricks and shortcuts we have at our fingertips, cutting out some of that annoying management as we build our schematics, auto device tag and wiring, easily searching for symbols, and then at the end, our automated report and error checking. We did some copying and pasting to save time as well as cut down on errors. And we even did a black box to just show an example of updating and adding a symbol as you go. We generated our terminal strip drawings, numbered our wires, produced our output. And here are some key benefits. So as we worked through this, it was a matter of a half an hour as we built that schematic up. Here are all the things we would have had to handle manually if we were doing that in a different tool. So first of all, we created 3 pages manually as we drew that schematic, 56 components, 56 wires, 30 cable cores, but we also generated a number of pages automatically, the terminal strips, the reports that were generated at the end, and think about managing all of this data for every little change that you made in your design that we didn't even have to think about as we stepped through it. So we always like to say this lets you be an engineer and spend your time on the things that actually energize you and your design team. Spending less time on button clicks and audits and more time putting together these designs to make it out the